And let's move to the final presentation for this session. This will be from Thomas, who is the Chief Operation Officer at the Trenz Electronics. He started working for the company 6 years ago as a working student, and now he progressed through various roles, including project management, before ascending to the management, and in the future he can actually be the face of the company.
Test 1, 2, 3. Can you hear me properly? Yeah. This is the one, okay. Then good morning, everyone. Thank you very much for having me. Two more things to add, actually. One to Michael that he just presented. If you're more interested in the AI tiles and how that's implemented on the Verso, we have a working demo on our table. And on the second thing I would like to add is I'm here with our technical colleague, who is the head of our hardware development, which is Vadim Yunitsky. He's standing up over there. So I'm not the technical guy, he is. So nag him, please. We're a company that is Germany-based, founded in 1992 as a sole proprietorship. We became a limited liability company in 2002. We now have 90 plus employees. I think the correct number is 102 by now. But to give you a little more insight, is half of that is actually in production. So we're a very small company, focused and based on FPGA solutions, but we're a bit of a unicorn because we also have everything else that you need. That would be the design resources, assembly resources, test resources. So we have roughly 24 engineers. Half of them are hardware development, the others are embedded software and firmware development. We're ISO certified. I know the building doesn't look like a lot, but let's wait for the last slide because we're currently renovating this one. And yeah, to give you a little more numbers, as I said, we roughly build 50,000 modules per year. So everything that you have heard before me, we can provide you with the hardware to implement everything. We have built more than 500,000 SOMs in our lifetime. And the number 500 plus customized modules does sound like a lot. I think this morning it was roughly 830 to be more precise. But we have that in only two dozen generations of SOMs. So we have some product families, but we have a very, very high degree of customization, deviations to make it more attractive to customers. All the designs that we have of all the standard shop products, so if, I don't know, who has worked with Trenz before? Who knows our products? That's good, thank you very much. So everything that you buy in our shop is always designed for industrial applications. So the overall BOM is always industrial temp grade. The only limiting factor could be an FPGA, for example, to be more cost sensitive. So you could start with the commercial temp grade for evaluation and have a more cost sensitive approach. And then once you have validated a system, you can then go to industrial or even space or military grade components. That's the short description of what I've already said. So the integration of FPGA and SoC modules means the overall market. So we are not only AMD focused. We do AMD, we do Altera, former Intel. We will do an Phoenix pretty soon. We have done Lattice, Microchip, Cologne chip. So there's everything already there. So you don't have to evaluate it yourselves, but you could leverage our resources as well. What I mean with rapid prototyping is pretty easy. We have 2 SMD lines in-house, which are literally next door to the development departments. So we can assemble the boards in the morning and hand them over to the developers in the afternoon and have pretty quick feedback. He occasionally dislikes that, but that means that we can have very short turnover times. And if we do find any issues or if customers have complaints, we're very tightly connected. So that gives you usually the step ahead of having to rely on different and multiple subcontractors. As mentioned before, everything that we do have is designed, manufactured, assembled, and tested in Germany in our single location for now. I know long-term supply and obsolescence management sounds like a nice word. We're living that. Let me give you an example. Who of you knows the Spartan 3? We have just discontinued that last year. And I think all of you know how long it's in the market. So our overall approach is, as long as we can get components, we'll build that. And even beyond discontinuation, customers are still possible to supply us with chips that are discontinued, for example, so you can have very, very little impact on your design. So I would like to talk about 3 different paths in particular today, which is basically the customization from scratch, then the adaptation or the extension of existing boards, and the completion of systems. On the left side, you can see a standard SOM, what probably everyone has at least seen or worked with before. So these are mainly the standard shop products that we have, SOMs plus matching baseboards. These can also be customized, adapted, but usually customers prefer a more custom approach. So we started from scratch. This is a customer, a medical customer actually, that's US-based. He approached us because he has used our SOMs before, but he wanted to have a more rugged environment for his board. And he was very keen about signal integrity as well. So we had to delete all the connectors, place everything on the single PCB. So this is literally, you give us your requirements, and we can then start implementing that from scratch. Another possibility is the implementation. So what we have done in this, So let's see. On this little corner here, you can see an FPGA. This entire board is also another medical customer. In the beginning, he used connectors and used this as a baseboard and plugged in different FPGAs. Same scenario, he evaluated that system once it was qualified. We neglected all the connectors, and we were able to place the SOM that he used before right on the PCB. And then for existing hardware, so this is based on a standard product that everyone in this room is able to buy. This customer had to have some adaptations, but not just on the hardware side, but what we also do is then we can propose cooling solutions, enclosures, software adaptation, or write the complete software for you as well. We can implement your custom firmware as well, so we can provide you with a complete final solution that can delete subcontractors and makes it significantly easier to bundle all your IP and to not have to discuss with multiple sources. So and then there's, let's call the smaller little baby, which is assembly variants. That is a service that we offer on all the existing SOMs that you can find in our market. And to add some more numbers to that, what you see if you go in our shop is 70% of the rough overall portfolio. 30% are customer-specific projects, which are obviously all under NDA, so we cannot share that, but we have significantly more expertise than you might see in the first approach. Assembly variants are variants on already finalized SOMs that are in the market, where a customer would like to change files, neglect connectors, or change and neglect memory. As long as we can stay on the same PCB, we do not charge any NRE for it. That's a customer service, so we can provide you with a better, maybe even a more cost-sensitive approach, or because you want to validate different systems with minor changes. So you have a very high degree of flexibility, and you're future-proof, because if something does become discontinued, we don't charge you for that, we replace that, and you have a new board. And then one thing that that will look familiar to Michael, as he just presented, early access programs. That's something that is very important to us. So we are a premier partner with AMD, which is the highest level of partnership. What we usually do is, as soon as they have the bright idea of coming up with a new FPGA family, we're usually involved at the earliest part. So for the Versal, we have worked with the engineering samples, pre-production, and then finally with production series. The board on the left side, the development kit that you can see there, has been built 2 years ago, already working with pre-production silicon. So that's what we mean that we are the step ahead. We are able to validate a system before the silicon was available to the broad market. What we've done this year is we've shrinked it further, and we've already released the SOM for the Versal as well. I think, Vadim, we have one here, so if you're curious about that, he should give you more insight. The same we do with Altera and Intel. We do have a strong AMD focus, but we also do all the other ones. So for the Agile X5, I don't know if some of you are already working with those. There have been some delays, discontinuations, but same situation. A chip is being announced. Once we have pre-production silicon, we will build the first board. I love the tagline, families with many children, but we're good parents, we don't have a favorite child. So what we can do is, you can have a single baseboard and run multiple generations and multiple FPGAs on a single baseboard. As you can see, we still supply the Spartan 6 as well, where we still have very high demand for, and it's an old chip. So what does it mean? We have scalable performance on a single platform. That means you can you have your baseboard that you would like to work with. It can be ours, it can be yours, but it gives you the chance to scale up if you need to have that for different projects. Therefore, you can also have a reduced time to market because you already have a validated baseboard and a validated system where you just change minor parts. The simple product line as well, single baseboard, and you can then have all the adaptions. The extended product lifecycle is something that is then similar to what I said before regarding the assembly variants, because same situation here. If something does become discontinued, for example, the Spartan 6 in, if I'm not mistaken, 2035, then you can still use Zinc 7000 MPSoC on the same baseboard and system. So that gives you the consistent footprint for the overall final assembly that you need. So you might not have to change an enclosure, or if you implement it deep in your system, then you will not have any kind of physical change or dimensional change. Additional services that we do offer is if you have validated a SOM of ours, but you're uncertain with your own baseboard, with the design that you have done by yourself, we can review schematics free of charge of your design. So we can, for example, or it's not just an example, but we always do that, is to check for proper power sequencing so you don't burn the FPGA on the first bring up. We do supply cooling solutions as well. Obviously, this is something where we need significant input from you as well, because you know how much heat the FPGA will produce according to the code you're running. So that's something where we can support, but not fully provide you with a solution. It's a joint approach. Same with the custom test scope. We do have 3 approaches of testing in our facility. We have manual tests, which is usually what's happening with prototypes. So once the boards are assembled, the hardware development will actually bring them up the first time. Then we have semi-automatic and fully automated test systems. Within those fully automated test systems, we can also program your CPLD. We can program the firmware. We can give you the little additional services that you can neglect them on your side and not have to lose a lot of time. And you have more transparency because everyone knows what you're going to get, and no one has to touch the boards again, have to check if it's the proper revision or anything. And then free customer support. So we do offer the support in English and in German language, 24 hours basically, via email preferably. Our approach is that we have a single email address, which is support@trenzelectronic.de, where all the development departments, so hardware, firmware, and embedded, have access to, so that you will always get the proper response from the department and the colleague who knows best about it. Free download area sounds normal, everyone has downloads, but the thing that we do add for SOMs, for every single SOM that you buy, you can download the schematics, you can download the BOMs, you can download step files free of charge. For all the baseboards that we supply, you can download the full Altium project of that specific baseboard free of charge, so that you can use it as a foundation point for your own design. Because you can leverage our knowledge. We know that this board has been running before, we have built it, we have evaluated it, and you can adapt it to the point where you deem it necessary in your situation. That's a bit loud. But it gives you... No, it's okay. I'm not going to talk. Let's go. So that was my part. I know I'm ahead of time, but maybe someone has a question.
Thank you. Questions from the audience? So I actually have one. So I guess you were not here yesterday during the talk from Sophie. Basically, we were discussing the future of FPGAs in high energy physics in general, and what basically the requirements most of that we have are typically for the moment for the upgrade that we are doing here at CERN are basically large boards, because typically we need a lot of space to put more FPGAs on that with a large platform like ATCAs. And with a lot of transceivers and optical connectors. So I was wondering what's the experience of Trenz on this aspect, if you are able to supply this kind of demands from CERN, let's say, or for future experiments. Let's think about the future.
What I know for sure is CERN is already using a lot of our hardware. So yes, what you're looking into is not a standard approach. But that's something that we do, and I think we have even done custom boards for CERN before. But as you stated yourself, more ADCs, more DACs, and higher bandwidth is becoming more and more important. So I think what we have done with the CERN was basically RF socks. So that's something that might be interesting, and we can discuss that.
More questions? Okay, if not, let's thank Thomas again.
Thank you very much.
And now we have the coffee break just outside, and please visit the sponsor exhibition.